Okay, good afternoon, everyone. Just want to introduce myself. My name is Suraj Krishnan. I'm the Vice President of Engineering at Relic, and I've been with Relic for the last 2 years or so. And my background is SaaS, cloud platform, infrastructure, cloud migrations. And today, I'm just really, happy to talk a little bit about Relic's journey in terms of our move from data center to the cloud. I just want to talk a little bit about our platform, talk about our journey overall, and also the lessons learned overall as we went through this process. And so with that said, let me start with this. Just to get to a little, appreciate the scale of what we were talking about, right? So New Relic is an AI first, all-in-one observability platform. And we have about 85,000 customers, and we pump in about 7 petabytes per day, and there are about 400 million queries is what we run per day. And overall, in a month, in a year, we have about 3 exabytes of data that gets generated. So you can understand, appreciate the volume that gets processed in our platform. Now let's talk a little bit about what our platform itself, because this will set the stage for the overall cloud migration and how we went about doing that. So all our customers, and we have about 700 integrations, our customers send 7 petabytes of data per day through our system, and all of them are HTTP requests that comes in through our CDN layer. And customers send metrics, even logs, traces, all of those data gets pumped into the system. And once it gets done, and the objective of our platform is take the data that's in sockets and actually persist them for our customers, so that we can actually decorate it and action on it and provide insights for our customers. To do all of this, we have a proprietary New Relic, time series database that's a fully distributed database that can actually scale and also provide the right level of latency, because the latency has to be in milliseconds for all of the queries to actually happen. Right, and that's the secret sauce that we have in terms of the NRDB, and that has it's a streaming platform, and we also have a data at rest. And finally, this data gets processed and it's stored, which is available for customers for any type of a query that can run, ad hoc, unstructured queries that they can run across. And this data is also stored across geographies and across regions. So one customer's data can be split in multiple regions, and still when a customer runs a query, the answers need to come in milliseconds. That's kind of like what the platform does. And again, it monitors and helps customers monitor and analyze all the telemetry data that they bring in. And typically all of this telemetry data comes through instrumented libraries in their applications, from their mobile devices, JavaScript browsers, and all of the data comes in and then stays in one location, which is our NRDB platform. And then finally it provides alerts to customers and also provides insights when they have an incident. Now a little bit more in terms of our metrics. If you look at the availability, so our customers use New Relic as part of the mission critical applications. So they use New Relic to monitor their mission critical applications. So if we are down, they are down as well. So that being the case, reliability is going to be very, very important. So we promise 99.9% reliability for our customers, and that's going to be very, very important. And as you can see, there are about 12 billion events processed per minute. That's the kind of processing that we do, and this is perhaps the world's largest telemetry data cloud. And again, we have been in this business for the last 15 years at this point. Now the secret sauce, as I said, is the New Relic database, which is the NRDB. This is a proprietary database that we have built specifically for time series data. And if you see the data that gets processed here, is all of the data comes through the CDN layer, and then we have a smart routing mechanism. And again, one is to store the data, and the other one is also to respond to queries that nearly happens. And if you look at the queries can be simple, it can be really complex queries. Now, the data for these queries can be in different regions because NRDB is a distributed database. So you have to go and once a complex query is run, we have a smart router that breaks the complex query into simpler queries, and then it sends to the right regions and the right cells that we have. It gathers all the information and then puts entire thing back again, right? And for the customer to actually receive the data. All of this has got millisecond latency in terms of how the processing gets done. Now, one of the things though, so we were in the data center, and so we were managing DCs and we were managing POPs, and that's where that's what we grew. We created the APM space, and finally, we were using Kubernetes at the data center, but it was one single monolithic Kafka cluster is what we kind of used for all the streaming capabilities. At some point of time, it became too huge because we were growing at breakneck speed. The overall storage and processing kind of like doubled, every year for us. It was very, very hard to keep up with that. And also, it's not just keeping up and storing the data and providing the right level of latency. It is to maintain the reliability and the availability which customers really care for. And that's when we knew that, hey, it's time to modernize, and we have to look at other options because data center, although we did that for several years and we were good at it, that's not our core business. So why do we really spend all our time, in managing that? We are in the business of providing insights to our customers and then preventing incidents, being proactive. That's where we want to spend all our engineering time in terms of how we want to actually modernize with that. Then so this is where the choice of a public cloud comes in. Given our massive scale, and given that we want to spend all our engineering time on actual innovation and not focusing so much on the infrastructure, and we also want to have the capability to scale as needed, right? And that's why we had to choose public cloud. And as we moved it is a gradual, iterative approach is what we took to move to the public cloud. Now, choosing AWS. Why did we choose AWS? There are multiple reasons for choosing AWS. If you look at AWS DNA, they have amazing set of services available for the type of scale that we really want, right? And they also bring in a lot of operational excellence as they move it. And then they have, a fantastic set of services that can be tweaked and tuned, and all of them are API driven, and one builds on top of the other, right? So it was a seamless choice, and we were using Kubernetes and we were using Kafka. So all of them, and we are also using distributed database. This is not the NRDB that we're talking about. This is a database outside of the NRDB databases. We also have several other data requirements that need to be met. Everything was available at AWS. So and again, it's the partnership that was very, very critical as we put the whole journey through. Now, I don't know how many of you listened to Werner Vogel's keynote. Right, and one of the things that he talked about in this reInvent was 6 things that he talked about, right, in terms of the future. One of the things that we talked about was cells, how important it is to reduce the blast radius and how to contain everything in the form of a cell so that everything is isolated and they're also interconnected, so that a failure in one does not impact the failure in the other, and everything forms as a building block. So we adopted the paradigm of a cellular architecture, the cell architecture. This was done, I'm talking about like, 4 years ago, right? And although we talk about this, cellular architecture is something that you can actually Google for. And here what we do is we take the footprint that we have in the data center, take about this, like we have one data center, one DC, you can create n number of mini DCs in AWS. And all of the DCs are self-contained and they all can be scaled independently as well. So that's the cellular architecture. This means that if I have 2 cells, if one of my cell goes down, only 50% of my customers are impacted. If I have 10 cells, if one cell goes down, only 10% of my customers are impacted, rather than the monolithic architecture where something goes down, your entire customer base is impacted, right? So this adoption of a cellular architecture was really critical as we moved. And when we started this, we had one leg in the data center and one leg in the cloud. We started to have a proof of concept. We put together 2 cells, and primarily our logs and metrics were primarily driven out of cloud, and the rest of it was operating still from a DC. That's the first step, and we did the proof of concept, and we actually had a big spike. And when that spike happened and one of the cells couldn't really scale, we moved the workload to another scale. That kindly proved the proof of concept that we had, and we became a little more confident in terms of taking this architecture in terms of where we wanted. Right? So this is what is the minimizing data. This is all the cells, and if you see, there are different types of cells that you can have. You don't have to have cells that are all uniform. You can have cells that actually meet your particular service requirements, and you can actually build those cells as well. Now, launching Cumulus. What is Cumulus? Cumulus is the name of the project that we gave for moving from the data center to the cloud. And we started with discovery. We started with a proof of concept that I just spoke about. We put together 2 cells. We worked with AWS team. We got all the services that we had in place, and the managed services that we wanted to use. We went with EKS, and we went with MSK for Kafka, and we went with Aurora for our databases, and then we put together all of this. And the cellular architecture is also made possible because all of the services that AWS provides have the fantastic APIs, so you can actually build cells and you can actually decomp cells as well, because cells is not something that's going to be living forever. Cells is something that we can constantly, we can rebuild and destroy cells. So that way, all of the updates to whatever we want to be doing is actually replacement rather than an update to an existing cell. Right. So data platform to the cloud. What is the timeline? So it took us a year in terms of how we did this. Now the most important thing, as you see here, is that we started with the data type. So this is all about the gradual movement of what we want. So it's not all or none kind of a situation. We started with metrics and traces first with the things that we have in the cloud, and everything else driven out of data center. And also we have to pick small customers versus large customers, who will go first, and then the type of data. Do you want metrics, events, logs, and traces? And then we have several data types, but these are the 4 major ones. How do you want to gradually move all of them, right? And it took us a year for us to gradually move this. So think about this as your car is running at 150 miles an hour, and you're trying to change the vehicle's tire, right? And as you're going at full speed. That's all, because as we do this, we didn't really stop operation for our customers. Customers were still on. They still require, the 99.95 reliability needs to be maintained, and we still need to move the workload. And how do we make this possible? When we do it in an iterative fashion, right? So this is a journey to cloud success. We'll talk a little bit about that, right? In terms of, so this was what you see, what we had in the data center, and we took what we have in the data center, and we created a CDN layer. And the CDN layer is something that we chose Cloudflare and Fastly, because that's where all of the data that gets ingested from our 85,000 customers, all the applications and all of that gets processed through that. And we have a custom routing in the CDN layer that routes to different types of cells that we have. And you see all the cells that you see. These are all the different cells. We took the DC footprint and we created a mini DC across, and each DC is basically a cell, and it's attached to an AWS account. And then we create this smart routing layer that can route across all of this. And what we did was we had both the cellular architecture and one foot in the cloud and one foot in the data center. So as we gradually move one data type to another data type, segregate the customers, and move smaller customer first than the mission critical customer first. So we have to go through that particular strategy, right, in terms of what it is. Now, as we build this, now things, as I said, the NRDB today, if you look at it, if you look at the NRDB database, it is actually distributed across. So we can actually go and store one customer's data in multiple cells, in multiple regions. But when a customer does a query, automatically you need to go to each cell and parse the data that you really want, bring them all together, and then make that available to the customer in milliseconds. And that's the challenge that we have from an observability standpoint perspective. So that's why we have to get in the query router. And the query router is a smart router that actually does this job of scatter and gather, in terms of what we want, and it can go to other pieces to actually make it happen. Now, one interesting thing about New Relic is New Relic runs on New Relic. So we monitor all our customers using New Relic. So that is, we have a production monitoring environment and a production environment. And both of them are, are New Relic's own platform. So this is the best thing that's happened. So what we did in this process is, instead of touching the customer's environment first, we chose our own New Relic production monitoring environment and started to make that move. So that way we can get to understand what happens when you move a data type, what happens when you have a large query. And based on these learnings, then you actually do the production move. And this is a very, very unique thing, because I've worked with hundreds of customers in my career. This is a pretty unique architecture in terms of what it is. So eating a dog food, a lot of customers talk about, but this is a very unique environment where 100% of all of our customer base, right, 85,000 customers, are monitored by New Relic's own environment, which is the production monitoring environment. And that is a very important way for us to experiment on things. So now, although we have run our own self-managed Kafka and self-managed Kubernetes containers, we have all done that in the database, but we wanted to move to a more managed service. So this way, we wanted to get out of the data center, because data center move, we actually canceled the lease, which means that we are now moving towards it. The date is already fixed. You need to go and complete all your moves before that, right? That being the case, we wanted to make sure that we pick up a service that actually fits into our 99.95% profile, and our engineers can actually allocate their time to actually doing a migration rather than trying to run Kubernetes cluster at scale, right? So that is the case. That's why we chose these two services. And then AWS worked with us, of course, because we are probably one of the largest Kafka clusters in the world, right, in terms of our streaming platform. So they learned quite a bit from our usage. We learned quite a bit from them to get to the 4.9 availability that we really want. It was a fantastic partnership as we established both on the EKS side and on the MKS side. And gradually what we did was, we took our self-managed Kafka cells, we gradually moved workload from those cells as we build these cells, and then gradually decommission the other cells. So that's why the cellular architecture is so clear, because you can actually move the data. You can move the existing data, or you can actually, all the new data that comes in, the CDN layer can actually move it to different cells that you want. So no longer go to the old cell that has self-managed Kafka. Hey, here you move it to the cell that has MSK and EKS. So gradually move the workload the way that we really want. Now, the question that always comes in is, hey, when you do cloud migration, just a lift and shift, or do you modernize and then lift and shift, or you lift and shift and then modernize? What we did was, we took a kind of like a hybrid approach. In some cases, we actually modernized certain components and then we did a lift and shift. In some cases, we did a lift and shift and then modernized. Specifically, when it comes to EKS platform is very powerful. There's a number of features that you can adopt, but our services need to be also attuned to that. And we were not at the maturity that we really had to be. So we actually moved to EKS, and then we spent another quarter or two to optimize all of the things that we had to do. And remember, we are a SaaS company. A SaaS company, there are only two things that's important: your revenue and your cost. Your cost cannot just go haywire. You always have to keep an eye on the cost. So cloud gives you a scalability, it gives you reliability, but it also needs to be cost effective for a business to run. So that's an important aspect as you do your cloud migrations, right? And that's what from a monolithic on-prem, and when we moved, it was kind of like a hybrid strategy that we kind of like followed. And again, all of this with the help of the routing layer that I spoke about, and how we moved the routing layer had the capability to move from the old self-managed architecture to managed services architecture that we have, and we seamlessly kind of like gradually moved based on the workload that you had at that point of time. So that helped us to kind of like have a way for us to monitor what is happening, at the same time gradually move the workload in terms of what we want. And you see here, you have New Relic cells, and you have New Relic cells with EKS and MSK. The New Relic cells are cells that were running self-managed Kafka. That is Kafka that we ran on our own, containers that we ran completely. They were also cellular architectured. Then we built new cells that had EKS and MSK built in. And gradually we shifted the workload from the cells and decommissioned the old cells that we had. So it was kind of like a step-by-step approach. From a data center, you have 1 foot in the data center, 1 foot in the cloud. Then gradually you build what you want in the cloud, and you move from cloud to cloud as well. Okay, this is like what we call as a this is a beautiful chart, which is a very, very popular chart within New Relic. This is how this shows the type of the length of the overall migration. It's about 12 months that you see on one side. And this is the different types of data types, different types of cells that we built. And you see how our volume has grown in our time series database. As we were doing all of this, it's not that business is static. It's not that business comes to a standstill. You still have customers pumping in data. Our business is growing, and that's how the whole thing. From 2 cells, now we have hundreds of cells that is in operation at this point. Okay. Now, all the data ingestion, as I said, we took a modular approach and we took an iterative approach to do it. But we completed the entire migration in just within a year. And as we did this with the right reliability that we wanted, and the reliability of our entire platform improved massively after we moved from the data center to the cloud. Now, what are the lessons learned? Again, I want to talk about 4 important lessons learned. Observability, right? So the good thing is we are an observability company. So whatever we do, we want to know what is happening and where is the problem and how do we remediate the problem. And what are the other dependencies that we always want to know. So as we did our experimentation, we used New Relic platform to actually monitor all of that, right? And that is a very, very important. You should be able to visualize the data. So okay, you move from data center to the cloud. What is happening? How is the latency? What is the performance? What is the scalability? Where are the problems? Where are the spikes? All of that needs to be maintained. So we use our own platform to look at and observe on what is the behavior in the data center and what's the behavior in the cloud, and appropriately tweak as we kind of like move forward. And again, even the changes, we know some changes are less risky, some changes are of a higher risk, and some customers need to be handled differently than the other customers. We worked with the customers as we did this migration so that they are aware of what we're doing, and we kind of like work with them in terms of any downtime that we needed. There was hardly I think that in 1 year there was hardly any downtime and maintenance that we asked. There's no concept of a maintenance or downtime in our business overall, right? We always need to be up and running. But when we see a performance issue, we should be able to detect it and solve it. Now, in a SaaS platform, in any kind of a modern SaaS platform, we always pray that, we don't pray that we should never have issues. Issues are 100% going to be there. As we scale, as we bring in load, issues are going to happen. All that we pray for is we identify it faster and fix it faster. That's what we can always hope for. And so detection is very important and remediation is very important, right? And that is what is very, very critical in the SaaS platform. Nobody can really say, hey, there should be no bugs, right? Bugs will always be there. Systems will actually, have issues. But you should be the first to detect it and not your customer, and you should be first to remediate it. Or you should be the first to inform your customer of what really happened. Now, as part of a platform, we can visualize this entire thing across the board. You can visualize the dependencies. It is a high cardinality, high dimensionality kind of visualization that we have as part of a platform. All the entities and where things are flowing and where is the bottleneck can all be visualized in our platform. That really helped us. We used New Relic to monitor both the data center as well as AWS in terms of what was going on and make it all happen. Then this is a chart that we use every day. We kind of like we had hundreds of we have we had about 954 services moved from data center onto a cloud. Every single day we had a chart that actually tells what is the burn down and how we are moving, and what services are in DC, what services are in in the cloud, how do we monitor this, and what is actually happening. Then all of this tagged by teams, the services, so that there's accountability in terms of who's driving what and how things can be done. Right. The second lesson learned, this is a critical one. Don't plan for the happy path. It's what you plan on paper. They always say that plans are nothing, but planning is everything, right? You need to plan for it. That doesn't mean that all the plan is going to come through, but so we've got to certainly not plan for a happy path. And there is a reason. We encountered all the things that all the problems we can have. So this is when we were hit, COVID-19 times. There is a shift. We also changed. We used to be on a subscription model for our customers. Then we moved to a consumption model. Big change in our business in terms of how we do contracts, how we work with customers. Then we launched several products with that. Our data ingest doubled during that time. Then we also had great resignation. So all of these factors were in play as we did the migration, right? Of course, nobody's going to get all of this at one go. This is probably, we were very, unfortunate. But certainly every migration will have things that you don't encounter, and you need to plan for that as we go forward. Then continuously build new cells. See, the cellular architecture was put together like 5-6 years ago. Today, Werner Vogels talked about it. And I think that's the fourth or the fifth thing that he talked about in terms of the future, right? The cellular architecture is so critical because it helps to isolate issues, and it helps to reduce the blast radius, and it also helps you to be compliant. So every 90 days, we actually rotate all our cells. So you can actually make use of chaos engineering, and you can say that, hey, you can go and randomly kill cells. Your cell should automatically come up and then automatically help you with the reliability that you really want. That's kind of like the path that you can go to. Second thing is, you don't have to, if you have vulnerabilities, if you're going to remediate within 90 days, probably you don't even have to go and fix the bug. You just incorporate all the new packages in the next one, right? That's what Kubernetes and some of the other things do in terms of having an immutable kind of like a platform in terms of what you want. Okay. Now cells, all cells, now we have hundreds of cells, but they are also of different types of cells. Some of them take care of stateful services, like we have the alerting, right? Basically the alerting cell, it takes input from other cells, and which is stateful services, and helps to alert our customers in terms of what they want, what they have set up as alerts, or things that can be driven from an AI driven option. So the cells can be of different types, and feel free to experiment with that, right? And we have at least 8 or 9 cell types that we use, and each of them can scale in its own way, right? One of them, you can scale it, hundreds of cells can be in place, some of the ones maybe in dozens, because it depends on the scaling that you want for each team. Then geographic expansion. Now you can have cells in different regions, right? You can have different cells within North America, you can have cells, you can have cells in Europe, you can have cells in APAC. As you build more regions, because you need to build more regions, because if you have customers in EMEA, if you have customers in APAC, you want to actually drive your queries and your data closer to your customers. There are also compliance requirements like HIPAA and and FedRAMP requirements. We have separate cells for that. There are FedRAMP cells, there are HIPAA cells, because the compliance is very different in those cells, and who operates on those cells are also very different. So all of this is all possible, with the cellular architecture. Then the last but not the least, invest in planning and communication. Now, when we talk about investing in planning and communication, involve your customers in this. So this is not something you involve, not just engineering, you involve engineering, finance, sales, marketing. Everyone in your company need to know about this cloud migration so that they can be sensitive to this. You should also involve and partner with your customers so that they are aware of it. They can be a little more, conversant with all the things that's happening, so that if there is an issue, they don't have to be in the dark. So communication and planning is so important, and this is not something that can be done only for one organization, but across the board. Now, one other important thing as you communicate when it comes to cloud migration is, most of the cloud migration, you will see a cost escalation. And the budget, if the budget is $100, people spend $200, right? Suddenly after they go to the cloud. So you have to democratize access to the cost to the service teams. So your engineering team, your service teams need to be aware of the cost of the services that they run. So we put together a FinOps team, and the FinOps team comprises of finance, engineering, and then FP&A. All of them work together, so that on a daily basis we look at the costs and we set up anomalies. and and make use of the features that we have in our own platform, so that every team will know what exactly they are actually working on. Now, the other part of FinOps opportunities is not just looking at the cost and managing the cost. You will invariably see a lot of opportunities to optimize your overall architecture. And that is a very, very important thing. So any SaaS company cannot survive if they are static. They need to be built to evolve. So your architecture need to be in place so that your architecture can evolve. You look at services like S3. I mean, it's been there for a decade or more, right? And still we can make use of the same features, but they're still keeping building features on that. Similarly, every SaaS company need to look out and evolve, and how that platform can be evolved, so that it's easy to build things as primitives, and everybody builds on top of that, right? And that being the case, once you go from a cloud to from an on-prem to cloud, whatever optimizations that you have done during this process will not suffice. You will see a lot of cost overruns here and there. You will see things that you're not monetized for your customers, and things that you have to optimize. Like, for example, networking will be a huge shock anyone who moves from on-prem to the cloud. It's a huge, the egress cost will be very different. You need to come up with native solutions that are available in AWS. There are solutions that are outside of AWS. You need to look at some of those things. You need to look at your operation, because if you take the well-architected framework the way it may be really cost prohibitive for you. Because if you're going to have redundant components, if you're going to have data move from region to region or from cell to cell, you're going to incur a lot of cost to that, right? And your customers are not going to pay for that, right? So you have to optimize it. So that is a trade-off. But the key takeaway is for you to look at this on a daily basis and have sufficient engineering bandwidth to optimize the architecture post-migration. Probably you'll have to spend like 2 or 3 quarters or even more, depending on your situation, to optimize post-migration. That's going to be very, very important, because there is another session that I did. We saved close to $20 million post-migration just on optimization. We spent a year on that. And we are still on the path. So it's not a one-time thing, because as new features come in, as new ways of doing comes in, you have to look at all of that. Okay. Now, all of this would not have been possible without the partnership with AWS. They were with us from day one as we did discovery, as we encountered issues, and they're one of the really mature teams to kind of like help. And then at any point of time when we have had incidents during this process, they were always available. They were very, very mature operational team, and a support team and an account team, and also the architecture team that we can actually get some of the things that we had questions on was always answered on time. So it's a very customer-focused, customer-driven team. So a lot of this is, I would say, it's also the collaboration and the partnership that we had with AWS. Okay. With that said, I'm going to close this out. I'm happy to take any questions. I'll be around here. Thank you.